we are ready to talk about an absolute value equation and an absolute value inequality. So before we do that, let's make sure we remember what absolute value means. The absolute value of a number, written as this right here with the two vertical bars, that stands for the absolute value of x, and it is the distance from 0 on a number line. So for instance, the absolute value of x is 5, means that x would either be 5, because 5, the absolute value of 5 is 5, or negative 5, because the absolute value of negative 5 is also 5. The absolute value equation, the absolute value of ax plus b is equal to c, as long as c is bigger than 0. So let's make a big deal about that. C needs to be, let's highlight that, c needs to be bigger than 0. And the reason why is because c represents distance from 0 on a number line. So the absolute value of ax plus b is equal to c is equivalent to either ax plus b is equal to c or ax plus b is equal to negative c. So for instance, what numbers, so like if that would be a, let's say the absolute value of x is equal to 5. This is 5 spaces from 0. 5 spaces from 0. So what two numbers are 5 spaces from 0? Either 5 or negative 5. And that means as x is equal to 5 or x is equal to negative 5. So an absolute value equation is always a compound sentence, and it's always an or compound sentence. So we're going to solve these equations. The absolute value of 2x minus 5 is equal to 9 would mean, remember, this is 9 spaces from 0. I'm going to keep telling you that. 9 spaces from 0. So that means that 2x minus 5 is equal to 9, or 2x minus 5 is equal to negative 9. Then we just solve the two equations. So we're going to add 5 to both sides, divide by 2, and get 7. Or we're going to add 5 to both sides here. Negative 9 plus 5 would be negative 4. And we divide both sides by 2, and we get negative 2. So either 7 or negative 2. And 7 and negative 2 are both solutions. Okay, sometimes we have things on the side with the absolute value sign. So the first thing we have to do in this case is we have to get absolute value by itself. That's the first step. So we're going to add 1 to both sides. And we're going to divide both sides by 3. So then we'll end up with the absolute value of x plus 2 is equal to 3. Then we can write our two sentences. So we don't write our two sentences. Don't write your two sentences until after you get the absolute value by itself first. Then make two equations. So we're going to say x plus 2 is equal to 3, or x plus 2 is equal to negative 3. So we get x is either 1 or x is equal to negative 5. Okay, let's go to the next one. Okay, these two are special because notice we've got an x on both sides, but we still have the absolute value sign by itself. That's what we want. Before we write our two sentences, our two equations, we want the absolute value to be by itself. So that's what we want. So we want 3x plus 2 is equal to the positive 4x plus 5, or 3x plus 2 is equal to the opposite of 4x plus 5. And the opposite of 4x plus 5 is negative 4x minus 5. So now I'm ready to solve the two equations. So let's see. If I subtract 3x from both sides, I get x on this side. If I subtract 5 from both sides, I get negative 3. 2 minus 5 is negative 3. And if I add 4x to both sides, I get 7x. If I subtract 2 from both sides, I get negative 7. So I get negative 1. And so in this case, it is important for us to check our solution. So I'm going to change my color to red, and I'm going to check my solutions. So I'm going to say the absolute value of 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5. Is that true or is that false? That's how we check our solution. Remember, the solution is what we can plug in for the variable to make the sentence true. So this is negative 9 plus 2, which is negative 7, is equal to negative 12. Negative 12 plus 5, which is negative 7, and this is not true. So negative 3 is not a solution. And if I plug in negative 1, 3 times negative 1, plus 2 is equal to 4 times negative 1 plus 5. So that would be negative 3 plus 2, which would be negative 1, equals negative 4 plus 5, which is 1, and that is correct. So the only solution I have here would be negative 1. Okay, let's do that one more time. Let's change our color back to black here. Black, okay. So we're going to write negative 2x plus 9 is equal to 3x plus 10, or negative 2x plus 9 is equal to the opposite of 3x plus 10, and the opposite of 3x plus 10 would be negative 3x minus 10. And then I'm going to solve both equations. So I'm going to add 2x to both sides and get 5x, and subtract 10 from both sides and get negative 1. Divide both sides by 5, and I get negative 1/5. Or I'm going to, add 3x to both sides, so I get x equals, subtract 9, and I get negative 19. So now I'm going to check both of my answers. I'm going to plug in negative 1/5. The absolute value of negative 2 times negative 1/5 plus 9 is equal to 3 times negative 1/5 plus 10. Is that true? Let's see. That would be 2/5 plus 9 is 9 2/5 equals, that would be negative 3/5 plus 10. Negative 3 plus 10 is 9 2/5. So that is true. So negative 1/5 is a solution. And then I'm going to plug in negative 19. Negative 2, the absolute value of negative 2 times negative 19 plus 9 is equal to 3 times negative 19 plus 10. So negative 2 times negative 19 would be positive 38. 38 plus 9 would be 47. And negative 3 times negative 19, oh gosh, what's 3 times negative 19? Let's see, it's 57. So negative 57 plus 10 would be negative 47. So this is not true. So negative 19 is not a solution. So the moral of the story here is we want to check our answers, don't we? We want to check our solutions to make sure that when the variable is on both sides, we want to check our solution to make sure that the solution that we get from doing the algebra, the correct algebra, actually makes the sentence true. And sometimes it doesn't because of the absolute value. Okay. The solutions of the absolute value inequality, the absolute value of x is less than 5, include values greater than negative 5 and less than 5. This is the compound inequality. X is greater than negative 5 and less than 5. Let's highlight that. So absolute value of x is less than 5 means x is in between negative 5 and 5. And the absolute value of x is greater than 5 means x is outside the interval from negative 5 to 5. So you can say x is less than negative 5 and greater than 5. We should say or there, shouldn't we? Let's change that to or. So, the absolute value is less than, so the absolute value of x is less than something means and compound inequality. The absolute value of x is greater than something means or compound inequality. Let's look at the examples. The absolute value of 2x plus 7 is less than 11. So we're going to write 2x plus 7 is less than 11, and we could write it as in this. Let's write it like this. 2x plus 7 is less than 11 and greater than negative 11. And then we're going to solve the compound inequality. So we're going to subtract 7 from everything. So 11 minus 7 is 4. Negative 11 and negative 7 is negative 18. We're going to divide everything by 2. X is less than 2 and greater than negative 9. So when we graph 1, 2, 3, 4, 5, 6, 7, 8, 9. When we graph on the number line, we would want an open circle, wouldn't we? And we want a shade in between. And if the absolute value of x, 3x minus 2, is greater than or equal to 18, then we want to write an or statement. 3x minus 2 is greater than or equal to 18, or 3x minus 2 is less than or equal to negative 18. So we're going to add 2 to both sides and get 20 greater than or equal to 20 over 3, or we're going to add 2 to both sides and get negative 16. X is less than or equal to negative 16 over 3. So then we're going to graph our solution on the number line. So remember, when we graph an and compound inequality on a number line, we graph the intersection, what they have in common. And when we graph an or compound inequality, we graph the union of the two, which means we don't worry about whether or not they intersect. We graph them together on the number line. So 20, always put 0 in the middle. 20 over 3 is 6 2/3. So I'm going to put 20 over 3 over here and put a closed circle because it's greater than or equal to, and I'm going to shade on top to the right. And negative 16 over 3 is negative 5 1/3. So I'm going to put negative 16 over 3 here, put a closed circle because we want to include less than or equal to, so we want to include this boundary, and then I want to shade to the left. So notice when we shade our intersection, it's in between. We shade our union, it's on the outsides. So what we have here is a little wrap up of what we just talked about. The absolute value of x is equal to a. That means that the distance from x to 0 is a units, either a or negative a. If the absolute value of x is less than or equal to a, the distance from 0 is less than the a units, so it must be in between. And it's going to be in between means it's going to be an and compound inequality. And if the absolute value of x is greater than or equal to a, that means the distance from x to 0 is greater than a units. So in order to be greater than a units, you must be on the outsides of a or negative a, which means we have our or compound inequality.